Hello, this is a possibly building site episode 19, but I want to make a bit of a break and talk about GraphQL, which is a technology I think everybody might have heard of from Facebook. And it's an interesting area for me. We've done a lot of projects at Juxt that have involved GraphQL. It's if you have a graph at the center of your organization, it's a wonderful thing to consider adopting, and yeah, I like it a lot. And there's a big movement towards adopting GraphQL that's particularly amongst people involved in the Jamstack, and I think it's an important technology to support in site. And in Clojure, we have pretty good GraphQL story in Licinia, but I want to take it in a slightly different direction. One of the problems I have with Licinia is that it's built on an older version of GraphQL where the spec is, well, GraphQL has its own schema language now, and I'm keen to support that. And I've been playing around with GraphQL for a couple of years. So I think I want to just play around with GraphQL, and this is the beginning of a new branch, I guess, of the building site series. So I'll introduce this by showing you what I've already been working on. There's a site, there's a repo that I've just put up today called Grab. And in the grand tradition in Juxt projects being four-letter words, I thought Grab kind of neatly sums up what you do in GraphQL, which is you sort of go to a service and you grab what you want. So this is right at the beginning of Grab, although I did a lot of work last summer playing around with GraphQL, and I've been thinking about how to support GraphQL in Site and in Crux. I feel that rather than trying to come up with a common schema language between OpenAPI, which uses JSON schema, and GraphQL, it's better to just respect the schema languages that have been established already and accommodate them within Crux. Now, Crux is a wonderful database to do this because, of course, it's schemaless, and so it allows this natural evolution of schema and application or user-oriented or user application governed schema to take center stage. So rather than being forced to encode your form, as we call it, in terms of the structures of the database, which in a relational database, Postgres, for example, would be in DDL, the benefit of Crux is it allows you, or allows us, to be fairly more organic and true to the domain that we build, and we can choose to adopt whatever schema approaches we like, whether that's JSON schema, whether that's DDL, GraphQL, XML schema, relaxing, or whatever. So anyway, that's Grab, and I am going to grab a copy of Grab. I'll pull out the copy this one. Or in fact, I will just clone it my normal way with -p, or say Juxt Grab. And that will appear here. And then we shall run some Emacs. And I'm going to increase my Emacs resolution. I don't really know how to do that apart from this old way. We'll have a play around here, see if we Yeah, that's slightly better. We've had some, I had a comment the other day about the font on this series being too small, especially with YouTube, and when it when you're watching an SD uh, rather than watching in 4K. And I want to make this series accessible to as many people as possible. So I'm going to increase the font, but it means that I'll be able to see less code, but that's okay. Now this grab. I need to pull out I've got a branch here. Let's have a look at all the branches. In particular, there's a branch that I want, which is called, yeah, no, that's right, the master one. What I will need is a branch there's one dependency on here, which is the Reap project. And I'll talk about Reap in a minute. I'm just going to check that I've got the right, I haven't even got Reap. Let me explain what Reap is. It's a project I wrote, I don't know, a couple of years ago. And Reap, I think Reap is a very interesting project. The problem it tries to solve is the problem of taking strings, usually in kind of internet headers or defined in a language called A, B, and F. So the syntax you see in a lot of the internet specifications, the RFCs, are frustrating sometimes to parse, and you need to create a parser for them, and some of them are very non-trivial. And Reap's approach is to use regular expressions, which I think are underrated, are very, very composable, and I prefer regular expressions and hand-built parsers, not just for performance, but I think it's a very elegant approach, and I prefer it to writing grammars with grammar pre-processing tools. And I know it's quite fashionable to use a grammar preprocessor, but I really like the regex approach, and I think this is what, Reap is really demonstrating how to compose regular expressions in a way that you can then build up an entire language, and I think that's useful from that point of view. And I have got a little branch that I've been playing around with, which adds some support in Reap for GraphQL grammars. So the idea of Reap is that well, it's meant to have built-in support for all of the HTTP headers and many other things that you might have to parse if you're doing internet protocol work. So in particular, I'm looking for this GraphQL namespace, which I don't know when this was written, but a while ago. Okay, so let's bring in Reap, and let's pull out this. I think that's what I do. I'm going to check out that, and we can now go to our grab. This was a project that was incubating in Site, and I don't think it really matters, and it doesn't really make sense to incubate it in Site anymore, and it definitely deserves to be its own project, as I think the idea here is that it's going to be a GraphQL engine that any Clojure project could take on if they wanted to adopt GraphQL, a bit like Licinia. And Licinia, definitely like Licinia, and I've used it many times. So this is, I guess, an alternative to Licinia. Let's jack in and see how it goes. So I have a test here. I think it was a schema test. Let me see. I'm just getting the latest version. I've got this schema test here, so this gives you an indication of what we're trying to parse. So if we look at grab, this is a test. If we look at, I'm going to have to parse that. Yeah, that's an interesting one. Let's see if we can just pull that in. We still have that problem. Just going to look at the, so this dependency is on reap, but it's quite subtle the way that reap solves the problem of circular dependencies, and I'm going to just solve that by yeah, okay, so that worked. Implements interface was the thing it was complaining about, and when that happens, I think it's because I need to have a var reference, but I'm not entirely sure. I'm going to start Emacs again, actually, and I'm going to pull in grab, just to see if I've solved the problem. Now I'm using a local version of reap because I'm going to co-evolve these libraries together, and deps.eden has this feature that I can bring in a dependency from my local system, so it won't work for when I commit, but it's allows me to quickly make changes to reap locally, and eventually I'll commit and change this to a real version. Okay, I think we're ready to run. Let's go to the test, schema test. Yeah, that worked. Okay. So what does this do? We look at parse. This is going to decode a document. Now, how I work on this project is that I have a GraphQL spec. I'm going to use the June 2018 version, the pre-COVID version of GraphQL, because that's what most of the tooling is built on. When the later version comes out, this is a working draft and it's still being changed, so when that comes out then I might upgrade, but at present everything I've built is on this version. And 2.2 talks about a document being a list of definitions, and this grammar here is expressed in a closure code. I call these parser combinators. These are similar to Haskell parser combinators in that they allow you to create a parser and build up parsers and compose them. But this is when we say that this document is a list of definitions, how we encode that is we say, well, that's list in this spec means one or more. There's a parser combinator for one or more, which takes another parser and creates a parser which will parse one or more of that thing.